to review just a little bit what we did yesterday in the activity. When I had some students come up here, we collected data. We let the ball roll down the ramp, which was actually in a PVC pipe, and we measured it. We measured the time. When we did it in the first one, where we were going longer lengths of the ramp, like a 3-foot ramp, a 4-foot ramp, we ended up with a graph that was mostly linear. Okay? And we said that the relationship was that as the ramp length increased, as it got longer and longer and longer ramp, the roll time increased at a constant rate. Then we did our second version of the experiment where we changed the height. We had it 1 book high, 2 books high, 3 books high, 4 books high, and so forth. And this time the graph ended up having this downward curve to it. Okay? And so we described that as the platform height increased, the roll time decreased because it went faster because you're going up higher and gravity pulls it down faster. Okay? But at a decreasing rate is how we described that. Then we did an activity where we just circled and put check marks. Y'all remember the check marks? Yeah. Right before we left class, because we had no homework, I had actually drawn a comparison between this. I said the tax that you pay in Michigan, 0.06 is the tax rate times the purchase, and the circumference is twice pi times the radius. Those two were related. We also noted that the cost to go to a party, cost per person, was $225 divided by the number of people that I invited, or the number of people that were going to split the cost. It's also the same as the speed of the race, 500, that was the Daytona 500, that's 500 miles, divided by the time. Now, the two equations on the left and the two equations on the right are related, and I need you to understand what they are as we move forward. We have a lot to do today, and I want to get to the point where we're solving equations, and we need to do it so that we can have time to finish some stuff in class. Here we go. All right, I want you to understand the price of the tax. The price goes up. As the price goes up, the what? The tax goes up. If I buy something that costs $5, I'm going to pay a little bit of tax. But if I buy something that costs $500, I'm going to pay more tax. So Miss Jessup's going to wave my arms around. I'm going to do these hand motions, so I want to make sure that it makes sense to you. Notice that if I had to write the letters on a proportion, I can put a 1 under it, and my P is on top, and my T is on top. Same thing with radius. If I have a small radius, I have a small circle, and the circumference is how far you go around the circle, so I would have a smaller circumference. If I have a much larger radius, I'm going to have a much larger circle with a much larger circumference. So again, my R is on top, my C is on top. So as the radius goes up, the what? Circumference goes up. Okay. Raise your hands up. Hold your hands up. Everybody's doing hand motions. Okay. So, what if the radius goes up? What happens to the circumference? It goes up. Okay. Next thing, put your hands back down. See if you can make a decision. What if the radius goes down? What if the radius gets smaller? What happens to the circumference? It goes down too. Okay. If the radius got smaller, the circumference would get smaller. What if the radius got bigger? Then the circumference around it would get bigger. Do you find that your arms are moving together? They're moving together. If one goes up, the other one goes up. Or if one goes down, the other one goes down. Does everybody see that relationship? That's how it behaves on the ones on the left. Now let's take look at the ones on the right. Where would you put your C? Where is it? On the numerator or the denominator? Top or bottom? It's on top. Okay. Where would you put your letter N? On the bottom. Now, it acts that way and it looks that way. That's what I want you to connect. It acts that way and it looks that way. If the number of people goes down, if somebody doesn't come and I only have a few people, then when we divide 225 by a small number, the cost per person goes up, right? Now, if I actually had the reverse happen, what happens if a lot of people show up? If the number of people goes up, then the cost per person does what? Goes down. Do y'all see that instead of working together, what does this side do? They work in the opposite. So if one goes up, the other one goes what? Down. Or if one goes down, the other one goes up. So in one relationship, we're working together. In the other relationship, we're working opposite. That's what I need you to understand as we move forward from yesterday. Now, we're going to call this a direct relationship. We're going to call this one, guess what? Inverse relationship. Now, I did have some students once that says, hey, if it's direct, how come I can't just say indirect? It is actually, it just depends on who you're talking to. And it depends on what author of what textbook. And in our math content, they do use the word inverse. So if you say to me, hey, it's indirect, Miss Jessup, I'm going to say, yes, you're right, that goes on. Because that's the same thing. Indirect and inverse pretty much are interchangeable. So it just depends on how they choose to what vocabulary they use, and they're using the word inverse. So you're going to see inverse on your final exam. I don't have no doubts that you're going to see that. Okay, so we're moving on to today's stuff. Let's go to this one right here. Everybody got this sheet? Do you see the first 8? Okay, I'm going to do the first one with you, and you're going to have about 30 seconds to finish the rest of all 8. You ready? Okay, all I want you to do is decide, is that a direct description or an inverse description? Number 1, as one variable or factor goes up, whoops, you put your eye. As one goes up, the other one goes up. Direct or inverse? That is direct. I'm just fine with you doing a D. Let's do number 2. When one variable goes up, the other one goes down. That's inverse. Now I'm going to pause and let you read carefully 3 through 8 and see if you can decide, are they describing a direct relationship or an inverse relationship? All right, let's see how you did. Number 3, the amount of money made increases as I work what? More hours. So that would be a direct relationship. Did y'all get D? What'd you get for 4? Indirect or inverse? Anybody get inverse? Okay, let's read it and see. The more I watch TV, the lower my overall GPA gets. Yeah, I have to agree, that's inverse. What'd you get for 5? I'm hearing inverse, inverse, inverse. The more people who play the game, the fewer number of turns each can take. Yep, that's inverse. Number 6. They're saying inverse again. When I run the air conditioner more hours, the temperature inside goes down. Well, 3 inverses in a row. Number 7, the more I study, the better my math grade gets. That's direct. The more I study, the better it gets, which means your grade's going up. The perimeter of a square gets larger as a side is increased. So if I have a square and then I make it bigger, the perimeter is going to get what? Increase the side, perimeter gets larger, it's direct. So what do you think? You got an idea now what direct means and what inverse means? Okay, that's where we're getting started. Okay, this is a few notes. It's already got a big box around it, but this is the meat and bones. This is definitely like cutting to the chase. If it's direct variation, the equation will be, and this is a generic equation, we're going to be doing a lot of direct relationships. They're going to have letters in them that are not y and x. But this one, if I had to put x on top and I had to put y, they're both where? X is on top and what? Y is on top. Okay. I also copy that same information over here on the side of the board. Okay, on the whiteboard. It's going to be there all week until Friday. Then I'll erase it before we take our test. But it's going to be there so we can go back and look at it. Now, if you all notice, there is a constant K. In every single problem that I just did, in every scenario that we just talked about, there's always a number. 2 times pi times r, 2 pi. There was $225 for the fun house. There was 0.06 because it was your tax rate. Those are numbers that stay constant. If I pay tax in Michigan, I pay 6%. If you go buy something, you pay 6%. That's a constant rate, okay? So this K letter stands for constant K. Now here's the question. To solve for constant K would yield an alternative equivalent form of the equation. In other words, it's going to be a different equation, but it's going to involve all the same letters. How would you solve this for K? If you wanted to get just the K by itself and leave the K, how would you get rid of X? You would have to divide out the X, wouldn't you? Okay, and if you divide one side by x, you'd have to divide the other side by x. So when you cancel out your x, your equation would be what? Write yours in the box. K would equal the y number over the x number. So basically, there are two versions of the same equation that are basically the same. There are two equivalent versions of the equation. Now, Ms. Jessup does not want you to have to worry about memorizing a bunch of equations. I only want you to memorize this one because that's the basic one. If you need to solve for constant k, you could easily divide it out and figure out what you get. So I do not want you to clutter your what you've got to worry about by memorizing. All I want you to memorize is the basic direct and the basic inverse. Everybody good to move on? Okay, let's talk about inverse variation. Okay, take note. Where is y located, on the top or the bottom? Top. So I'm going to draw an up arrow. Where is letter x on the other side located? On the bottom. So I got one that's on top and the other one that's what? On bottom. That's the way it looks in the equation. That's the way it behaves when I think about it. So it's kind of a clue. They're written differently and they look differently. They act differently. Okay, what if I had to solve this for an alternate equivalent form of the equation? Which means I want to get this constant letter k by itself. How would I get rid of the divide bar and how would I get rid of x? I would times it by, well, I would want to leave k, times it by x. If you times one side by x, you'd do what? Times the other side by x. So when you canceled, you'd get what? Right in the box, the constant k is equal to what? X times y. Again, I do not want you to clutter. Don't clutter what you know. These two are basically the same equation. They both have constant k, x, and y in a particular configuration that makes them equivalent. But I only want you to remember one of them. Which one do you think I want you to remember? I only want you to remember the basic one. So remember the basic one of this one and remember the basic one of that one. Don't worry about the constants. I'll have them on the board for you to look at. Does everybody see them up here on the board? Okay, that'll be there for quick and easy reference. Now, you are going to have to put pencil to paper for just a few minutes. We're going to write 4 sentences. Now, in the 4 sentences, we're basically going to dissect the equation. Okay. Number 1, do you already have a C right here which says C equals? Did I fix it on your paper? Okay, I forgot to fix my board copy. Okay. Here's what I want to do. Do you see where it says the variable blank is? And it's got a blank proportional to blank with constant blank. Y'all see the blanks? That's like my blueprint of a sentence that I want to write for number 1, 2, 3, and 4. What it is it's going to make you pay attention to where the letters are located. So let's all start. Write small because I know you don't have a ton of space. You ready? The variable. Okay. Now, I'm going to put a blank there. What am I going to fill in the blank? The variable blank. Usually the first thing you see goes in the first blank. So what's the first thing I see? Well, it's not 225 and it's not in. The first thing is C. So the variable C. Now what does C stand for? Cost. And we just say cost. The variable C for cost. And then it says is. It says blank proportional. Can I abbreviate proportional P-R-O-P? Is it okay if I abbreviate P-R-O-P? Yeah. Proportional, because proportional is a longer word. To blank with constant blank. Now, let's just see if we can fill this in. You want to go ahead and write your sentence? I'll pause, let you write your sentence, leave your blanks. Every single part of the equation should fit in a blank. And then there's one word we have to just figure out ourselves. Everybody ready? Okay. The variable cost. So right away, we've already figured out what goes in the first blank. Everybody good? Now, take a look at the equation. Is it inversely proportional or directly proportional? Take a look at the equation. See if you can figure out which one it is. Is that an inverse or direct? Let's take a look at the letters. Where's C located, top or bottom? Top. Where's N located, top or bottom? Does that kind of give you a hint? When one goes up and the other one goes down, that's not direct, that is inverse. So I'm going to type in inversely proportional. Okay, you got to pay attention. Now, what's the cost inversely proportional to? What's the other letter? N. What does N stand for? Number of people. We'll just say number. With constant what? What's the one number that stays the same in that equation? 225. Now, take note. Every single part, 225, that's my what? That's my constant. The cost was mentioned first, and the number was mentioned in my second one. And then you have to decide. You only have two choices for blank proportional. It's either directly proportional or inversely proportional. Now, that was a little bit of writing, right? You can do it, can't you? Okay, let's do at least one more. Ready? The sales tax in Michigan is a function of price and can be calculated by the formula. Okay, I see the formula. Does everybody see the formula? What two letters are in it? T. What other letter? And what number? Nope. 0.06. Okay, so let's just go see. The T time, right? How did you know T time came first? Well, it's not T time. It's not time. What does T stand for? In this problem, it stands for tax. The T tax. How did you know that came first? Because it's the first thing you see. Whatever comes first goes first in my sentence. The T tax is blank proportional to blank with constant blank. See if we can fill it. Tell you what, why don't I pause and see if you can fill it in? Okay. Let's see if you can fill it in. You got 4 blanks. One's filled in, second one, third one, and fourth one. See if you can fill them in. See if you're paying attention to what the things are. So we're saying P price. I keep doing that. P price with constant what? 0.06. Did anybody get that filled in? We have not yet filled in our second blank. What should go in the second blank? Why is it directly? Because T is what? Up when P is up. Does everybody get that? So you have one goes up, the other goes up. That's a directly relationship. So it is directly related. Okay. Can we? All right. We abbreviated number 3. We just said the words out loud and we filled in our blank. What will go in the first blank? The variable what? C circumference. That's a long word. Okay. Is blank proportional to? What kind of proportion is this one? You got to take a look at the equation. So C is what? C is up and R is up. Right? There's no denominators. Everybody good? And you're looking at letters. We're not looking at the constant. We're just looking at the letters. So this one is directly proportional to, and it's proportional to radius, which is R. And this is the variable constant a lot of people forget. What is the constant? It is 2, and it is pi. Both of those are actually representing numbers, right? 2 is a number, and pi is a number. So far, so good. We're just learning and understanding our language is directly proportional to, is inversely proportional to. We're learning how to recognize the equations as being direct or inverse. Which one has a bar in it, usually? Inverse. Has a bar, has a top and a bottom. That's usually inverse. I'm telling you, I don't know why. I thought this wouldn't be such an important unit, and I did not give it enough effort the last time. And what was on the test? Inverse. Inverse. And I'm thinking, oh, that's so easy, and I didn't even give my students a good chance. So you guys are going to have a good chance. Okay, let's go to the next part. No more sentence writing. This time all you get to do is write an equation. Can you do the opposite of what we just did? Can you pick apart words that are important, and can you write the equations that go with them? Okay, let's go through and see if we can find words. I'm looking for 4 parts. Okay, the what? Perimeter. I see a little word named is. Anybody remember what you do for is in math? What is is? It's my favorite little word. It's an equals. Okay, so every time you see is, it's going to be equals. Then I see directly proportional to. That's important. Okay, and then what is it proportional to?
S.
S for length of a side, S. Okay, now it says pick the letters that make sense, and you have to figure out the constant. Does anybody know what a square is? What makes a square a square? 4 sides. And they're not just any 4 sides, they're what? 4 equal sides. So if this is length S, what is every side? This is length S, this is length S, and this is length what? S. What's perimeter? You add them all up, walking. Imagine walking all the way around it. How far would you walk around it? So it's a distance around something. So what's the very first word I see? Perimeter. What letter would you pick? P. Then the next important word is, which is equals. What's it proportional to? S. Do I need a bar or do I not need a bar? It's directly proportional, so I don't need a bar. But I do need a constant. What's my constant? It did not give it to me, but I have to figure out how many sides I have. 4. Well, you had to do a lot of writing on that one, didn't you? A P, an equals, a number, and another letter. 4 things is all you got to write. But you got to read the sentence and pick out so that you can write the correct equation. Now, there are some. Okay, let's start number 6. The time required to download a 4 megabyte music file off the internet is. Right there's my is. So what do I know is? So some word to the left is going to be my first one. Time. What letter do you want to use for time? T. Then it comes is. Now, how is it related? I don't need the 4 yet. Inversely proportional. I have to have a bar on this one. You're right. Have to have a bar. So put a bar. What are you going to put on the bottom of the bar? Is it inversely proportional to what? The rate. Rate R. So rate goes on the bottom. Now, let's go back. Somewhere in here is a number that's very important. 4. What that's saying is, if I bought that song, it used to be when you had to buy songs all the time. I know a lot of you have music that's just streamed. Does anybody have Spotify, Apple Music, Pandora, some kind of music system? You have to pay for it. But it used to be you bought the music file and you download it to your device. I still do that. I still buy songs that I like, that I want to keep on my phone. If it's 4 megabytes for me, it depends on how good my internet is. My internet's great and it comes down fairly fast. The time, if the rate is fast, the time is what? Low. It won't take long and it'll down. What if the rate is really slow? Then the time goes up. So as one goes down, the other one goes up. Okay. I'm going to let you try 7, 8, 9, and 10. Pick out words. If it doesn't give you a letter, make up a letter that makes sense. Pay attention if it says direct or inverse. If it says inverse, you need to write a bar and then see if you can find the number that goes with it. All right, we've had a few minutes. Anybody want to tell us what you wrote for 7? Number of sheets in a stack. Whoops. Okay, you could use an N if you like it for number. Did anybody use an S for sheets? In my other class, I had somebody use an S, which is okay because it didn't specify. You could choose whatever you think. Then I see is. What comes that? Equals. It depends on whether you use N or S. Okay. Directly related. That's important, isn't it? You do not need a bar. It's related to the height. So, what do you use for height? H. There ain't no bar. With constant proportionality, what? 100. So 100 goes where? So that's what your equation looks like. If you happen to use S for sheets, that's what your equation would look like. Either one of those is correct because it didn't specify. Anybody want to tell us what you got for 8? Anybody want to volunteer?
Yeah.
What? F, all right, E. Efficiency is E equals, what'd you get? 200 over G. What gave it away that you knew you'd have to have a bar? Inversely. As soon as it says inversely, I knew that I needed a bar in my equation. How about 9? Charles, 9. Point 2. What is it? Oh, P for pounds? Okay. I think I use W for weight. Yeah, whatever letter's good. The fact is, did you need a bar in this one? No, because it was directly related. Are you understanding there's a difference between directly and inversely? That's what we're trying to get across. Last one. Who's got it? Besides you. Because you already did it. Okay, Miss Caroline. You did that one. 15H. Anybody else get P is equal to 15H? You can use A for amount. Yeah. All right. My goal for this first part yesterday was about getting it, kind of seeing a relationship in the real world. One of those was a straight line when we graphed it, and the other one was a curve, right? One was direct, one was inverse. Then we're seeing examples. How do you write direct? How do you write inverse? Do you understand the relationship? That's the goal of this. Now we got to figure out what do we do with it. Okay, on the back. Now we're going to do this in class. I'm going to give you about 15 minutes, and then we're moving on to another part today. Now, do not panic. This should not take very long. Okay. You're going to learn how to write an equation when they give you some information. Okay, I want you to go to the side. I don't remember if it's on the right or left. I think it's on the right. Go to the side that says directly. And at the top it says, he saw a whoa. Why was Grok excited? Was that what it was? Why did Grok jump up and down the first time he saw a variable in algebra class? Yay! Woo! Jump up and down. Okay. Every one of these uses the word directly. Are you ready? Okay. My equation says y equals k times x. Everybody good with that? Because when x is up, when x is going up, y does what? Also goes up, right? They work together. So this says, I need to write the equations. I do not know my constant, but I do know what? Y is 20, so what can I put right here? Y is 20. I could put 20, then equals, looking for constant k, and then x is what? 5. How would I solve for constant k? You divide by 5. So what's 20 divided by 5? 4. So if you put it back in there, 4 goes in, it's 4 times x, right? Everybody see how I got that? Basically, what did I do to get it? How do you get your constant every single time? Look right here. Look. How do you get your constant every single time? A y number divided by an x number. So if you want to go straight to figuring out the constant, that's how you do it. So which answer matches number 1? Okay, the basic equation is going to keep a y in it and an x in it, and we solve for constant k. Then we just put the constant number in front. So that would match what? SA. Okay, if you want to do the puzzle, which to me is kind of neat, but you don't have to, I think it was S and an A. Was it an S and an A? Yeah. Okay, go down here in the bottom, and you would simply put an S in one and an A in the second, because there's 2 1s. Does everybody see that? Okay. How do you get your constant every single time if it's direct? You divide. So for constant k, It's going to be a y number on top and what? X on the bottom. Which number goes on top of this one? 9. Which number goes on the bottom? 27. Guys, that is not 3. It's 1/3. Did y'all see that? Okay, you can use your calculator, but 9 goes into 9 once, 9 goes into 27 3 times. So when you put it back into the equation, remember y stays, x stays, and you're going to put 1/3 back in there, so it's 1/3 x. Do I see that answer anywhere? Yeah. It's NT. So this is number 2. If you want to do the puzzle, go to the bottom, go to where it says 2 and put NT. Everybody good? Now you are going to do the other one. When you're ready for the next page, raise your hand and I will walk you through how to do the second side. Everybody good? All right. If you've had a chance, I'm just going to go ahead and record how to do the next one. If you're going to go to the other side, keep in mind the equation's y equals k over x. X is down when y is up. That makes it inverse. To solve for constant k, you'd want to get k by itself, so you want to get rid of the x. So you would times both sides by what? X. So to get your constant, it's x multiplied times y. So letter O, the constant is 3 is your x, 25 is your y. Multiplied, you would get 75. Now when you put it in the equation, you have a y in there and you have an x on the bottom. So y is up when x is down. And what you need to do is put your constant on top. So the first answer is y equals 75 over x. And that is right here. The top part goes with this first row. There will be some left out. And then the bottom part goes with the bottom row. And there will be some answers left out. All right, we just finished practicing writing equations. When you write equations with direct, to get your constant, you actually have to divide your y number and your x number. That's what you did on the first ones. When you're actually writing equations for inverse, to get the constant, you actually end up multiplying the two numbers. Okay, so we did practice that. So, at the top, I think I have a place for you to summarize some stuff about direct. What's the equation for direct? Y equals k times x. The alternate version is constant k is the y number divided by the x number. So remember, those two equations are technically equivalent. They both describe direct equations. What's the inverse equation? Y equals, do I need a bar for inverse? Yes. K divided by x. And the alternate version is k is equal to x times y. Now that's just to kind of keep it fresh so you don't forget. Okay, I'm going to cut straight to the point. Tomorrow, you are going to be assigned to do the back of this sheet. There are 7 direct, 7 inverse. Tomorrow we're going around the world to start the class that's going to be mixed direct and inverse. Solving is not hard if you remember how to set up a direct, which is not the same as how you set up inverse. Okay, so pick your pencil up and write this down. Direct, go to that space where number 1 is and write this down. Direct. It has to be direct. You're going to set up and solve a proportion. Let me say that one more time. You're going to set up and solve a proportion. You have done that before. We haven't done it from many word problems, but we have set up and solved proportions before. We've crisscross multiplied. This only works if it's direct, okay? So my best advice is we're going to read carefully so that we know what we're talking about. Then we're going to read a part that tells me 2 numbers that usually go in the same sentence together. And then the last part will usually tell me something I'm looking for. Everybody good? Okay. The amount of interest paid on a loan, mine says load. I forgot to correct. Does yours say load too? Okay. Loan is directly proportional to the amount borrowed. Okay. Now, if you have highlighters, if you want to take your pencil, underline 75 is earned with a $500 loan. Does everybody understand? Those two numbers go together. I went to the bank. I want $500, and the interest is going to be 75 when I pay it back. Everybody good with that? I'm going to use those two numbers to write my first fraction of my proportion. I don't care which way you write it as long as you keep the words with it. So I'm going to write $75 earned over $500 borrowed. Now, writing the words, at least at first, will make you focus on making sure you put the numbers in the right place. Is everybody good? Now, I'm going to put a bar because we just said we're going to set up and solve a proportion. Now I'm going to keep reading. At the end, it's going to tell me something that's going to help me set up the other half. And something's missing. How much interest? $1,250 loan. I got to figure out, does $1,250 go on the top or should I put it on the bottom? Okay, it's a $1,250 loan. So does that mean I earned that much money in interest or did I borrow that much money? Okay, if it's a $1,250 loan, I borrowed it. True. But it's actually saying how much interest is earned. So X is on top. I do not know how much is earned. Now remember, this is supposed to be directly. So if I borrow $500, I'm going to pay $75 back. Am I borrowing more money? So this time if I borrow $1,250, what do I expect to happen with my earned interest? Should go up. Okay. Does anybody remember how to crisscross and multiply? And I suggest that you type this in your calculator one time. So let's completely multiply and divide and type it in one time because that's the most efficient way to do it. Multiply what? 75 times what? There you go. That's equal to what? 500 times X. Now, I don't want you to stop yet and put that in your calculator because I'm not finished. How do I get X by itself? It's 500 times X. I'm going to divide by 500. Divide by 500. Now pick your calculator up, multiply and divide one time, and this is going to be your answer. Anybody got it yet? It's over $100. I will say that. Anybody got it yet? $187 and 0.5, which in money amount would translate to 50 cents. Okay. Now, does that make sense for direct? $500, I earned $75 interest. $1,250, I earned what? $187.50 interest. So you borrow more money, you earn more interest. Okay, would you like to try number 2 by yourself?
Yes.
Okay, remember, you should have two numbers that go together and write your first fraction with those two numbers. Write down the words that go with those numbers. Then we go to this last part and figure out what you're trying to find and figure out where the other number goes, the best place. We have set up and solved proportions before. Okay, what'd you get? 100. Okay, did anybody set up 250 feet and that was the top of your fraction, and Miss Jessup is going to write down the words that goes with it so I keep my words straight. What's the second number that goes with that? 25 minutes. So on the bottom, I'm putting a minutes number. Now, other side of my equals is where I'm going to write my second fraction. How long will it take Bob to travel 1,000 feet? You got to decide, is 1,000 a feet number? Should that be on top or should I put that number on bottom? Because it's a feet number, I should put it on top. That's going to be the toughest part, is making sure you set up the proportion right. Does everybody understand? That's why I said keep up with the words. Feet should match feet. So X would be on the bottom this time. Does everybody get that? Make sure you follow the words and set it up the same way. Try to put this in your calculator one time. What's 250 times x? 250 with an x. What's 25 times 1,000? What do I do to finish this? Divide it by 250. It's not 10. It's 100. So the answer should be 100, and the bottom number should be X number of minutes. And that makes sense. If I go 250 feet, 25 minutes. If I go 4 times. Now, did anybody notice this? Guys, direct works this way. I went, look. Stop. You guys are rushing. Don't rush. If I go 250 feet, and then I go 1,000 feet, how much farther is 1,000 than 250? 4 times farther, isn't it? Is that 4 times farther? So it takes 25 minutes to go 250 feet. How many minutes does it take to go 1,000? 100? Y'all say 100? Is 100 4 times more than 25? And that works that way. If you double one thing, you're going to double the other. If one's 4 times bigger, then the other one's also what? 4 times bigger. It does work that way with direct. All right, the next two are inverse. Inverse. Guys, I can't say this enough. Do not solve with proportions. Proportions only work for direct. But I'm going to cut straight to the chase. Are you ready? Find the two numbers that go together, and we're going to multiply. Okay? Let's read it. A force of 200 N is needed to when the length is 1.4. So 200 and 1.4 go together. Do y'all agree with that? Yeah. That describes the situation when those two numbers came together. Okay, I'm going to write that down. Nope, write that down. It's going to be 200 times 1.4. Okay. I got 200 newtons. Is it kg on there? Okay. Don't matter. We just need the numbers. All right. Now I'm going to put equals. This solves differently, and I'm going to tell you exactly what I'm just cutting straight to the chase. I can explain to you tomorrow why this works, but this strategy is different. Okay. All right. Find the force needed to lift an object when the length is 2.8 meters. So this is a kg number on your paper, and this is a what? Meters number. I need a new kg number times a new m number. Well, what is my second m number? 2.8. And I don't know the force. So I'm going to put 2.8 right here. And I don't know this. I'll put an X right there. Did I do a proportion this time? No. I did a multiply for the first two numbers and a multiply for the second part. Everybody see that? How do I solve to get X by itself? Divide it by 2.8. So over here, divide this by 2.8. So 200 times 1.4 divide by 2.8. X equals. What is it? So see, I think the answer's a lot nicer. 100. And I want to say newtons because I'm used to forces in newtons, but if your paper says kilograms, then I've not fixed that. Now I want you to pay attention to this. May I ask you a question? How is 1.4 related to 2.8? Okay, when the length got longer, right? When the length got longer, what happened to the force? Force dropped. It went from 200 to 100. This is inverse, right? The length got doubled. The force is basically got 2 times bigger, and this one got 2 times smaller. Does everybody understand? Write this down. You're going to love this. I promise you. You're going to love it. Trying to find a pretty pen. All right. This is the shortcut to inverse. The students last year told me this was easier than direct. Multiply the first two numbers divide by the next number. Is that what we did? Did 201.4 come first, so we multiply those? And then did we divide by 2.8, which was the next number? Okay, why don't you try that on 4 and see what you get? Okay, this is inversely again. What two numbers? We're not doing a proportion. We're going to multiply. And it's inversely proportional. Yeah. Okay. Tell me the two numbers that go together, the first two numbers you see that go together. Okay. 420 hertz, 0.8. We're going to multiply those. 420 times 0.8. And then you're going to do what? Divide it by the next number. What's the next number? 600. Anybody got my answer? 0.56. Okay, let me ask you. When you go from 420 hertz to 600 hertz, did that go up or go down? That went up, right? Then my wavelength went from 0.8 to 0.56. Did that go up or go down? It went down. 0.8 to 0.56. So as one went up, the other one went down. Now, switch on the back. Actually, no, hertz and hertz, this would actually be meters. Yeah, on the back. One side is direct and the other side is inverse. Okay. Let me go back and say this one more time. How do you solve if it says direct? You set up and solve a proportion, which is crisscross multiply. How do you solve inverse? Multiply the first two numbers, divide by the next. It works every single time. If you can get the right two numbers matched up, that will work every single time. So inverse can be very fast to solve if you can find the numbers that go together. We're doing the back side, we're doing all of them.